So let's look at how we can quickly multiply and divide by powers of 10. So what I mean by multiplying and dividing by powers of 10, it's going to be 10 to the power of something that we're multiplying by. All right, and depending how many zeros we've got tells us what 10 to the power we've got. So in our first question, for example, we've got 1 with 1 0. This is actually the same as saying we've got 2.68 times 10 to the power of 1, all right, because we've got 1 0, okay? Now, when we're multiplying, that actually tells us very quickly when we've got a decimal, how many places we need to move the decimal place to the right. Okay, so we've got 2.68 times 10 to the power of 1. To find the solution of that, we simply move this decimal place that we've got here. Let's use a different color. One spot to the right. Okay, so our answer becomes 26.8 or 26 and 8 tenths. Okay. Now, if we're looking at some of these other examples that we've got here, we've got this 0.0782 times 100, which is 10 to the power of 2, because there's 2 zeros there, okay? And that helps us identify that we need to move the decimal place 2 spots to the right. So it's here, we need to move it once to there, but once more to here, okay? That's 2 spots. So our answer becomes 7.82 as the answer. So that's 7 and 82 100ths. The third example we've got here, we can rewrite this to be 13 and 83 thousandths times 10 to the power of, and the number of zeros we've got is 4. So it's 10 to the power of 4. So what this tells us, we need to move the decimal place 4 spots to the right. So 1, 2, 3, but we've sort of run out of digits here. So if we ever run out of digits, we add an extra digit. Okay, so we just add an extra 0 here. So now we've got the value of 130,830. Okay, so whenever we're multiplying by powers of 10, we count the number of zeros, and that tells us what power of 10 we're dealing with. Okay, after the 1 that is, and we move that many places to the right. Now, everything that we do in maths, well, pretty much everything has an opposite. So if we divide by powers of 10, we do the opposite. So if we're moving to the right when we multiply, we move to the left when we divide. So if we've got a number such as 27.9 divided by 10, we can think of this as 27.9 divided by 10 to the power of 1, which tells us we need to move 1 decimal place to the left. Okay, so that's moving to here, which is going to be 2.79 or 2 and 79 100ths. Okay. Our next question that we've got here, we're dividing by 100, which is going to be 10 to the power of 2. So we're dividing by 10 squared. Now that 2 tells us to move 2 spots to the left. Now this is where we need to just remember that our decimal place is here on a whole number. So 2 spots to the left will end up moving to here. And that will equal 7.82 or 7 and 82 100ths. Now with our third example, that 10,000 once again is 10 to the power of 4. So we've got 14,029 divided by 10 to the power of 4. So we're going to move 4 spots to the left this time. So it was here. It's going to go 1, 2, 3, 4. So we've got 1 whole and 4,029 10,000ths. Okay. So as you can see, when we're multiplying and dividing by powers of 10, we essentially count the zeros of our base 10. And I like to represent that middle line just because it's useful for something we do in the older year levels when we start looking at scientific notation. So getting to understand that 10,000 is 10 to the power of 4 is actually really, really helpful to identify for later on, which is the reason why I like to think of it like that now.